So this question says that we have a person on a swing, and when they sit still on the swing, they oscillate back and forth at some natural frequency. So I have a person sitting on a swing, and they're holding on, and they're swinging back and forth at some frequency, F initial. Now what we're going to do is this person's going to stand up on the swing in a way where they're now standing and holding on. And what's going to happen is that their center of mass is going to be higher. So in the original case, I'm going to say the center of mass is at the swing, but this case, the center of mass has now moved up towards the pivot point. And it says that instead, the person stands on the swing such that her center of mass is always directly between her feet and the pivot, or is directly between the two. So we're moving the center of mass up. Stand up on the swing, center of mass moves. We want to know what happens to the new frequency. What's our final frequency? Well, I know that a pendulum has 1 over 2 pi square root of G over L. And this is for a pendulum, not a spring mass system. And this is one of the ways that people can get confused, is it's for a pendulum. Well, in this case, G is always going to be constant. But the length that we change, we go from, the length is given by the axis of rotation to where our center of mass is. So in the second case, our length is smaller. Our new length is a smaller length, which means that this length gets smaller, this number gets larger. So the new natural frequency is greater than the original. So F final is greater than F initial because L final is smaller than L initial. The center of mass moves. If I move it up, you can actually see what I'm writing. So it says L final is less than L initial, which causes F final, our natural frequency at the end, to be greater, because we're using a pendulum equation. And this makes sense. If we actually think about this, I always like to go back to grandfather clocks and cuckoo clocks. Cuckoo clocks have small little pendulums on it. Their mass, the center of mass is very short, so they click at 1 second. Grandfather clocks have a really long pendulum. Their center of mass, the pivot to center of mass length is 4 times longer actually, and that will oscillate at 2 seconds. And this is why grandfather clocks, they click every second, where a cuckoo clock goes click, click, click. It's actually going a full cycle every second.